We're here with Steve Shalita from Pluribus. Steve, how are you?
Good. How you doing, Phil?
I'm doing very well, and and thanks for joining us. So I want to talk to you about carrier SDN. It's obviously transforming the industry, but Pluribus is doing something or talking about something that's a little bit controversial, I guess. You're talking about SDN without controllers. What does that mean, and how is Pluribus making that happen?
Well, that's a great question, and a lot of times I talk to people and say, we do SDN without the controller, and people have a hard time wrapping their heads around that concept because the notion of SDN has been about creating this control plane and separation of the control plane data plane and putting in a controller. But the problem is that doesn't really scale well, and I think it's been one of the significant obstacles to deploying SDN in carrier environments, in the enterprise as well. The idea of a controller running all these devices seems to make sense, but think about the picture of controllers running controllers, right? And when you're dealing in a carrier environment, a controller makes sense to orchestrate across a broad range of technologies. But then having a controller to run the network itself and then connect to a controller, which then gets controlled through software, makes it very, very complex. What Pluribus really has done in the innovation in the NetVisor operating system is built the controller into the actual operating system fabric that runs across all of these switch devices and eliminates that control point. But it doesn't take away the operational functionality that you want from a controller, meaning the programmability, the ability to define features and functions on a per box basis. And it actually gives you some advantages over controller architectures. Because I've distributed the controller, so that's the notion to get in the thinking here, is the function of control has now been distributed in a peer-to-peer like construct across a number of white box switches. Those switches all know state and the relevance across the network, and I don't have to go to a controller or a control mechanism to get my knowledge. So once I've done that, I can now place those devices anywhere. There's no physical, geographical boundaries anymore because I don't need to communicate with this device to tell the switches what to do.
What type of use cases does that open up for carriers when they get their head around the idea of that sort of flexibility of having having white boxes as opposed to dedicated hardware, having a controlling mechanism that's a little bit more easy to manage? Where does the carrier go from there? What types of things can they be doing?
Well, first is the advantage of the white box technology, which certainly everyone's talking about here, the notion of disaggregation. But what does that mean? Some carriers have had to actually build their own OS because there aren't a range of carrier-grade operating systems to run these white boxes. But then when you think about how do I build a network, if I've got multiple, if you're a mobile operator and I've got multiple MSCs that I want to run and operate so I can share policy, share visibility, and share intelligence, if you will, how do I do that? Well, I've done it typically through traditional networking, putting probes in the network and trying to basically interconnect distributed environments. With a SDN environment that isn't bound by a controller, I can now build a single fabric that stretches geographically across all of these MSCs and gives me one point of control, management, policy, and programmability across the entire network. There are quite a number of operators in their 4G and 5G trial environments that are running those fabric-based environments that gives them unlimited control without any kind of boundaries or borders.
Let's talk about another sort of facet of what you touched on there. As a carrier network is evolving, obviously lots of functions and jobs are getting automated and sped up, and that's having to deal with just the proliferation of devices and users and the bandwidth that's being used. But maybe you could contrast for us the difference between automating the network or automation that's handled by the network versus automation that's handled by external devices.
That's an excellent question, because a lot of talk around automation is, let's put a platform in there that communicates with all these systems and basically front in the automation. You're still doing things the same way. Let's write scripts and tell all these switches what they need to do. That's not really automation. And the whole notion of SDN is to create this programmability. What you get with a controllerless fabric environment is this ability to automate from within the fabric architecture itself. So the fabric itself is automated. So all I need to do is go to one device, tell it what to do, and it then spreads that across the entire fabric architecture, so all the other devices learn, state is changed, configuration policy is changed. So that's the benefit of the SDN architecture now getting distributed. I have one point of management, one point of control, and I can go and create automation that gets now integrated into OSS, gets integrated into application environments, so the applications can actually control the network directly in a more scalable way. And think about this in the context of an automation platform going box by box with scripts and telling the boxes what to do. That's great. It certainly removes operator effort, but it's still going to take time to proliferate that across the network. If the network itself is automated from within, you make one command to the network and it automates that whole process across the infrastructure.
Well, and there's an interesting sort of carrier issue that we've seen on the user side, is that you sometimes even geographically in the wireless carriers, you go to one geography and the rules are slightly different, or the login's a little different, or you're with the same company, but the interface, the rules, the network rules are different everywhere you go. With this sort of scenario, when a carrier makes a business decision or a decision for its users, it applies those rules and they're proliferating all throughout the network.
Absolutely. It not only applies it consistency across the network, but because the way next generation SDN works, it's built using high performance computing storage technology, so peer-to-peer clustering, if you're familiar with how that works in a computer storage environment. Okay. And within that clustering technology, it actually looks at all devices and their state, and it makes sure that they can accept the configuration and what you're pushing to it. If one device in that cluster can't accept it, it isn't rolled out. So you ensure consistency across all the devices, and you ensure compatibility. If the switches can't implement that policy, don't have enough storage or memory or capacity, the network doesn't change. And so that eliminates meltdowns too.
Yeah, a huge issue there, because you not only got proliferation of different devices, some devices not supported by certain network elements and that sort of thing.
Exactly.
And then you've got different applications, because users are downloading different applications at all times and putting those on the network. And now a carrier can just make a policy and know that whatever policy they put out there is going to be implemented. That must have huge implications for security as well, right?
For security, think of one other area, right? So carriers are talking about vendor lock-in a lot, and that's a whole conversation unto itself, because it's impossible to eliminate lock-in on a complete basis, right? It's really about multi-vendor interoperability. And now I can run a network with multi-vendor white boxes and ensure that those white boxes will interoperate and can consistently deliver the same features and functions. I can now start applying security policy, again, consistently across network on an end-to-end basis. And because the network is virtualized now, because it's more automated, I can start implementing other kinds of virtualization capabilities like network slicing.
That's a good segue, because I wanted to touch on the topic of network slicing. How does a carrier, when they're slicing the network, when they're provisioning different bandwidth types and allocations for different users, be it resell partners or whatever, how do they do that without degrading something along the way?
Well, the first answer to that question, which is a tough question, is what is network slicing and how do you implement it? And there's a bunch of different ways that it's being deployed. Some are being done at a policy level, some are being done at spectrum and at bandwidth, how I'm connecting to the physical devices. What we look at from a network perspective is how can I slice the physical network itself to align it better to the services that I'm delivering. So think of it as segmentation. Because our operating system actually virtualizes that switch, we're containerizing the network. So if you think of how VMware works, where I take a bare metal server, put VMware, and I create these virtual machines that are running separate applications. We do the same fundamental thing to the network. We take an individual network device, we decouple the hardware and the software, and then we slice the network into containers that are different virtual functions. They could be network services, they could be network connectivity, they could be VNF, NFV functions that are sitting on the top of hardware. Now they're mobile just like a container. I can move them across the network to any hardware device. And that could be a device that's sitting here in Austin, move it to a device that's sitting in New York City as a containerized service. So I'm actually slicing the network and giving each one of those slices its own services, its own routing functions, its own policies. So we're not sitting at an area above the network, we're actually slicing the physical network itself.
And not degrading the service along the way.
No, because you're guaranteeing your service quality, your QoS, your bandwidth on a per slice basis.
Fantastic. All right, Steve Shalita, thanks so much for joining us. I appreciate it.
Thank you, Phil. Great to be here. Appreciate it.